Okay, so we record. Okay, record in progress. Okay, we continue right now in here. So so far we come back again, right? So from the last that we demo, so we understand now. That's why we have the new app server in here, right? We advertise everything go back to VPLS, and from VPLS, and then it's going to be propagate through the BGP all the way down to the MPLS because we should be able access from the remote office, right? For example, the remote office in here, somehow we have a users in here. They want to access this new application server, right? And then they should be all the way traffic should be go through the this way, like this, go to VPLS. But just like from the last review, the last configuration, unfortunately, the traffic is go back to this guy here, go back to MPLS, right? Because like we have a BGP pairing with here, and this core switch 2 is propagate uh, the 10.100.60, that network here, back to the BGP here. And then this BGP here is propagate back to MPLS. And MPLS, the same thing, propagate to here, and this is the propagate to here, right? All the way back to here. Now, from the Verizon here, from the Verizon the VPLS router here, because it's because receive the route from this router and receive this route from this route. But when they had town, when they had kind of like BGP hub, see this is from here, right? One, two, and then from here, one, two, three. It sounds like here is more long path, right? For return traffic. So, and then the MPLS say, oh, okay, I might be trust this one because it's a shorter path, right? To be back to here. Now, this is nothing wrong, and just because uh, we have something in our topology here that our design, because somehow the cost switch one in here, because we cannot create a VLAN 60 because somehow we have a memory issue, something like that. So, and also this is a very good, for case study, right? And also since we don't have the VLAN 60 in here, because all the way in here we don't have a layer 3. Yeah, we have a yeah, we don't have a layer 3 because we pairing the BGP between here. We're using the layer 2 for the VLAN 1. So that's the reason it's crossing the trunk port. So when you're crossing the trunk port, and then if you don't have allow like VLAN 60 in the trunk port, so that's why the traffic is not going crossing this here, go back to the application server. That's why we fail. Now, okay, so we continue again. So I just refresh for you. So make sure we are on the same page, right? We are the network engineer here. We are on the same page. So what we should know what's going on, and also we should know how if we can switch around or something that we can reroute the traffic or something like that, right? Okay, so now in this case, so we go back to here again. So we know this, we know something here, right? We know something here that is the bad guy because it's propagated here, right? And I think we tried to using the a route map, right? I forgot which one we using the route map, right? So we tried not to advertise to here. I think this should be. I think this should, because this one back to here. Let's hop in quick in here. What is the, let me see here. Let me go back to the console here. If I remember, right? So let's go back to here. Command line. At the command line, enable again. So we show again, just make sure we show run section router BGP. So you have to be able like this. Okay. When you play every time, every day, so you should be, when you come into the command line, you should be know what you're doing. All right. So here let's review the configuration first. Okay. So we review. Let's find out. Do we have the route map on here? Right. The 00. The VLAN one. Oh yeah, yes. See, that's the leftover. Okay, we just cut off, from the last video. So we just in here. So we already, right? We already have this route map. So let's repeat again this route map what we do because this is outbound. So that is outbound. So that is mean everything the BGP advertised to our neighbor, right? So we apply with the we filter, we apply with the route map, right? So it's mean we have more control, so we can control what prefix not advertised to here, right? So this is good to refresh again. So then we can say show route. So we're going to show a route map, right? Show route map, that's the name. You see here, we hit enter. Now, so we have a two entry. So we have a, oh, look at it. We have a deny, right? So what is the deny? It means it match the IP address, the prefix list name. We call the name of this one, right? And then, so for example, if they come to this route map, they have to be in order. They have to be start from 10, 20. Now, from the 10, say, if I match, it's telling if I have the perfect list, match this one in here, I'm going to be denied. So that is mean this prefix network list here. So if I match this one here, I'm not sending it over to here. Okay, and then the 20, if I don't have a match anything in here, see, this is just like a open, like any end, right? So it's like if and else conditions. This is like if we match this one, we're going to drop else, and then we should be allow everything to here, right? So how we verify again is show IPBGP summary first in here, right? You see, and then we find our neighbor. So we use this command. We just want to verify show IPBGP. You see, show IPBGP neighbor. You see, show IPBGP neighbor, right? And then we grab this neighbor. This is the neighbor. All right. So this is the core switch one here, the neighbor. And then we want to verify advertised route. So that is mean what this router advertised to the neighbor, right? If I hit enter, so okay, look at that. So everything advertised, look at everything advertised from the core switch 2. So everything advertised, just we don't have the 10.60. You see, we don't have the 10.60 because we got filter from our route map in here. See, when we match this prefix list here, when we match this prefix list here, see in here, okay, show, you see, show IP prefix list. Okay, so hit enter. You see, we have a, you see, we have a, okay, we have a two entry. We have a default route, and also we have a prefix list name. This is the name of the prefix list. You see, and then that is the permit. We take a like C/24. Okay, so that is mean we got filtered now. That's why I mean this router once it's met. That's why this network is going to be dropped, not send it over to the neighbor. So far, so good here. Follow?
Mm-hmm.
Very good. So now, how we verify? So now, if you want to verify, we go back to this neighbor here. See this neighbor here. We go back to this neighbor. Right? We just look at the show IPBGP enable again. Show IPBGP. We just hit enter. We look at the BGP routing table. See, we have this 60. Okay, but this 60, you see, the 10.60 in here, see, is learning, you see, is learning is not from here. Okay, you have to just be see in here, see, this one here, the 60, you see, is learning, you see, from MPLS. Okay, all right, it's just confused, but this is okay or not, we don't know. Okay, but this one, since we block, we not send it over, but this one learn that network is from MPLS. The reason why from MPLS because we advertise to here, and then from the VPS router we advertise to the MPLS router, and then from the MPLS router is advertised to our backbone, Verizon MPLS, and then propagate to the rest of the MPLS cloud in here, right? So that is a mixin is coming from here, right? So now, okay. So how about from the if for example, right? I know we don't have access to MPLS Verizon, right? Sometimes if you want to have some troubleshooting like this, right? You can open ticket with Verizon. You can ask their engineer, say, hey, can you log into my uh, we call P and CE, right? C is the customer. We can say, hey, we want to, can you log in the pair with us, like between CE and PE? Okay, for example, this is the PE and this is the CE. We can ask them, open the case, right? Hey, can you do us a favor? We just want to know from your side, because we don't have access to their router, right? So we just want to verify, ask them, so verify from your side. Now, when you receive, right, when you receive the 10 dot 100.60, right? Now, are you going to prefer back to here? All right, the next up in here, right? So let's get, so for example, if we, in this case, because we are lab in here, we have access, we just go ahead and access to this router. Okay, so this is the third party, right? This is the vendor side. So same thing again in here. You see, when we show IPBGP in here, all right, so how we learn to the now, and then he said, no, you see, see, we're learning from, you see, we're learning from 10.60, who's the originate? 2552 select 2. Okay, oh, we don't have the AS number. No, we have a 2553, and then we have, this should be 2, right? 2, and this is 05. Let me see, let me mix sense 02, 05, perfect. And then it's going to 06. Yeah, that's the 06. 06, go back to here, the 04, and then go to here. That's perfect, you see. So now, you see, this Verizon MPLS router, he just learning only one path. You see, is from the VPLS from this side here. It's looked like correctly, you see. Oh, okay. So because sometimes if we ever tie back to here, see, if we ever ties back to here and then come to here, when this router receive from this side, and then he's going to be calculate. So that is mean he have a multi path on their routing table. And then he calculates, in here, see, 1, 2, 3, 4. Now, we assume if we don't have apply the route map, we can, same thing in here, see, the router is going to be head count 1, 2, 3. See, 1, 2, 3. See, 1, 2, 3, 4. That's the reason they're coming back to here. That's why we have a timeout from the last video when we ping, right? When we ping, we got timeout. Okay, because the traffic is going to this side. But we know we shouldn't go to this side, because this side we have a problem. One come to here. That's why we want to force everything the traffic to make sure it's coming back is from this side. Okay, from the VPLS here. Okay, that's so good now. So that is mean it's so far so good in our Verizon side. Okay, that's good. And then we just say thank you for the verify for us. Now let's hop into the switch here again here. Okay, hop into the switch here. So this is the remote office here. You see, this is the remote office, right? And then the remote office in here enable. So we just don't know anything. Okay, let's just pretend we have a one users in here, right? He ready to access now. Okay, he will say, okay, I want to access the applications in one server, right? So 100.60.6, I believe the sixth IP address, right? We just pretend and then we hit enter. See why? Still not able, still not happy. Okay, do we need to use any different source? Okay, maybe we believe, do we have a issue for the return traffic? Okay, so okay, let me say, okay, let me more specific in here. The 10.100, dark 60, dark 6. I want to be using the source from the VLAN 10, the marketing in here, the users, right? So the marketing people, they want to access the application one, all right, in here. You see? Now, can we ping? Mm, okay, fail again. See, what else? Well, okay. So let's trace route again. Just make sure again, trace route, right? We want to verify again why it sound like still not happy, right? Everything it sound like we configuration correctly, but it's still not happy. So we trace route again. Okay, we go to right 152. Where is the 152? Right, so 152 is MPLS, right? And then should we go to 152 again this side, and then we should be go to 190, 168, right? So let me see, it's correct or not. Yeah, see, we go to 168, and then one go to 168 in here. You see, but look at that. But when you come to here, the 4.3, right? What is the 4.3? This is 4.3 here. So here, this is the 4.3. All right. So this the stop. It's not like from outgoing, we call from here, because from here we say outgoing. From the outgoing traffic, it's look like perfectly, right? Follow the path like this is perfectly. The traffic is arrived to here. See, the traffic is arrived to here, right? And also, because this guy, we have a direct connect between the VLAN 60, this guy is should be able to ping in here, right? And somehow he got stopped in here. So he got stop in here. All right, let's kill this command first. All right. So we want to go back to here to verify again. So we go back to the cost switch 2 in here, right? The cost switch 2. See the cost switch 2 in here. We show IP interface brief. See, this is how we troubleshooting. So that is the same thing when you're in the production network. See, you should be able when you know all this kind of concept, the routing in here, and also the company using the BGP, you are perfect. You can jump in to their network, to their router or something like that. You don't have to worry. You don't have to be nervous. You should be good because that's why I'm training you in here. How you want to become strong, feel comfortable, feel confident, All right, so from here, you see, we have the variance 60, but make sure in here, so make sure, are we able to ping the 10.100, 60, 6? Yes. Okay, so there's been no issue, right? It's not no issue from here. I assume the packet it should be come to here too. So for example, if I open this one here, if I log into this switch here, right, log into the switch here, the workstation, the server here, switch here, right? Hit enter, enable, show IP interface brief first. Just make sure we have the 6.6 in here. Yes, 60.6. That is beautiful. Now, if I use the debug command, but just make sure again, when you're in the production, never put debug or like this. It's going to kill the whole switch in here, okay? Otherwise, if you remotely you have a problem. If you have no one on site, and then you don't want to do that because it's going to be locked to the whole switch, Even sometimes you fail with the console cable login. So have to be someone manually over there, have to be turn off, power on, unplug the power, something like that. So never debug all. So that is you have to be remember. Okay. So in this case, we want to be say IP, debug IP, right? We want to debug IP ICMP like this, you see? Okay, the debug is on. All right, we just want to prove it to see when I ping again, I should be see the traffic is coming here, request from the VLAN 10 in here, right? So let's go back to the Chicago switch one again in here, right? Let's go back to ping again here. You see, I ping it again. All right, so now let's see the traffic is coming. Beautiful. Look at that. Beautiful. You see, we prove it. The traffic is coming. So this means this here is received. All right, receive the packet, the ping packet is all the way from here. You see, all the way from here. All right, so there is mean nothing wrong now. So outgoing traffic, see, outgoing traffic is no issue. Come to here. That is one thing you have to be strong. You have to, oh, beautiful, right? Now, what happened now? You see here, he tried to reply. You see, he tried to reply from the source back to here. All right, so back to here. See, he tried to, all right, let's say undebug. So we unall. So we turn off the debug first. Okay, we don't want to be noisy. Now, from this debug, what is telling us from this debug? Okay, we can obviously, you see, we can see from the console here, because the switch say, I received the package from you. I try to reply because we have a send hello and send reply, right? Because that's what we call echo, right? So we have to be reply, but the but the problem is, you see, we try to reply to here. So because this switch in here, we don't know yet. This is layer 1 or layer 2 or layer 3, right? That's what I'm saying. If I show IP route is in here for this IP network here, so this is the network, right? Because that's the destination. So this switch here, do I know that is the issue? You see, subnet not in table. You see, so that is mean this switch here, I don't know how to go back because I don't have a routing. All right, and here, let me see. Just say show IP route? Did I run any protocol? Right? Do I run any protocol? See, oh, I have a static route. See, I have a static route. You see, right? I just have a static route. This is the network, right? You see, okay. So I assume, right? Because if you turn off this list, if you turn off this suite, it's like workstation suite like that, you have to configure as like the default route, right? The default gateway. But in this case, it sounds like the IP routing is enabled. So this means this switch in here is act like a layer 3 switch. You know what I mean? Okay. So in this case, you see in here, okay then, what is the two option that we can resolve, right? Because in here, because we don't have a BGP in, you say, something like that, right? Okay, okay, okay. So that is been in here. We have a limitation. We have no choice, right? Maybe this switch in here, maybe the old ISO like that, the like when you show version like this, the switch or the router, they give like sometime maybe say, okay, this is very old. It's not support like BGP. Just say for example, it's not support BGP. Okay, and also we don't have an OSP, EIGRP, something like that. Okay, so that is mean the only option we can use is just a static route. Okay, then I have no choice. And then I just using the static route, right? So now your mind is to be automatically, you want to allocate this switch here. You want to allocate this switch here. I want to go to get network, right? Via is the static route. So then you have to just inject quick in here. See, inject 10.205 .10.0, and then what is the subnet mask 24? You see, and then what is the next hub? The next hub should be 3. The next hub should be in here, right? So that's when you allocate this switch in here. Say, hey, if you want to go to the 10.205.10.0 network, okay, I will send it to you because you're supposed to layer 3. You're supposed to know that network. Okay, because you are BGP, you're ahead of me, so you're supposed to know that remote side of Chicago. Okay, so that's how I send it over back to you. So okay, so the next hop in here, so it's a 10.100.60.3. I hit enter, right? So now look at that in here. Now go back again. Now when I show IP route, okay, now when I show IP route, you see, now my routing table, you see, I have another static. It's telling me, right? If I want to go to the network, go back to this one in here. All right. It sounds like we have a return traffic now, right? It sounds like we have the return traffic. We should be able to ping now. Okay, so go back to here again. All right, let's go again. We ping it again. Watch. Beautiful. Look at that. You see, once you know all the routing, you see, just going and return. It's just nothing difficult. So far, so good.
Mm-hmm.
Yeah, you see, so it's not that it's not like something like as long you understand about BGP, understand the topology, right? You have to first thing you have to understand the topology, and you have to understand how you want to more control all the paths. Okay, you want to go this network to here, you want to go the network to there. So everything is controlled by you. The only thing that you need to know is understand what is the behind. Are they running the EIGRP? Are they running static rail? Are they running like OSPF? Or they only or running BGP? Something like that. You need to know what you can use their dynamic protocol, to help to advertise for this network or the back to here. Right now, it's already successful. Beautiful, right? Okay, so beautiful now. So we already have in here, we already successful. We configure this one all the way. So we already prove it from the Chicago back to here, to here, to here, to here, right? Beautiful. Okay, now, okay. So now, as unfortunately, so it became the server team, the application, the server team say, hey, I need to go out to the internet because I need to update my patch. Or for example, if this is the Windows platform like that, they need to go out to the Microsoft, right, to download the window update patch, right? That's what I'm saying. That's why he's going to be have a, ask for another request now from the application once the server team come to the network engineer say, hey, I'm not able to go to internet. Okay, let's verify how we perform now. Okay, all right. So let's go back to the switch one in here again. Go back to the switch one in here, right? Go back to switch one in here. Switch one. Where's the switch one? This one here. Okay, so if you go back to here again, right? See, for example, I just want to go out to test and go out the internet. 10.8.8.8. You see, 8.8.8.8. I want to say the source on purpose now. I want to say from 100, right? .60.3. This is application server subnet, right? I want to ping 8.8.8 the internet like this. You see. Mm, oh no, it should be .6. Sorry, see, because the three this is mixed up. It should be .6. Okay. All right. So now look at that. Hmm. 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 You see, it's timeout. All right. Okay. So now it's come to, now we have a ticket now. It's come to network engineer. So we have to investigate now, right? Do we have a problem go out the internet from this network, right? So first thing again in here, see now you tell me, you see, when you show IP route in here, right? When you show IP route, you see, this is exactly, you see, you don't know the routing for 8.8.8, right? You either want to send everything the default route, right? You can set the default route. You can set the default route, everything that if I don't know, I point it to here. Okay. But if you want more control, more specific control, like more limitation, right? You want to be like so powerful now. You don't want to rely on the default route on the backbone in here. All right. All right, then okay, then that nothing wrong. So, okay, so now same thing again. I go into here. I'm gonna say inject IP route 8.8.8.8 and 255, 255, 255. And the same thing again. We point it to 100. Our next hub is dark 3. All right. So now, see when you show IP route again in here, you see, now I should have a 8.8.8.8 in here, right? So now, are we able to ping again now? You see, now, do we have a ping again? You see, Still not working, you see. Okay, so this is how I baby step for you. We troubleshooting baby step. Okay, we from the bottom here, we should be follow like this, right? We go to here, but then you know that we're not crossing here, right? You have to be rely, or you have to send it to here, and then from here go back to the MPLS, and then from the MPLS you should be all the way go to here, and then you go to here, and then you go to here because there is internet router. So that has been wow. It sounds like wow. It sounds like it's more challenge now, right? Normally you should be from your topology design, you should be like come to this side, and then should be go here, right? Because same thing again, we leave it alone for right now. All right, so we just take it what we have right now, right? Okay, so that is mean we have the challenge now. Go all the way to here to here to here. Okay, but first thing in here, see, right? But first thing in here, we want to verify. We want to verify first in here. See here, all right? Say we want to make sure trace route first, right? We want to trace route 8.8.8. Make sure I go to the switch call switch two, right? I should be go to here. All right, let's think about. Come on, come on. Yeah, come on. Okay, and then let's see. This is a basic, like behaviors. We want to trace route first. How far we can go. Okay, how far we can go, and then we go from there. And okay, it says 10.02. Is that make sense or not? See, it sounds like come back to here again. See, it sounds like to come back to 0.02. Yeah, you see, it's come back and then go to 1.6 in here. Okay, you see. Oh, okay. It's not like go to here then, right? You see, it's not like go to here. You see, it's not like go to here. And then until here, we got stopped. You see, we got stopped. But we suppose we know the answer. Even we take this correct path to here, right? But when this internet router, when you return, see when you return, are we taking from here, or maybe it's taking from here? You see, it could be going from here. Maybe that's why we can have redundant link. Maybe the internet router is okay. It's when the return is take longer path like this, go back to here. Who knows, right? So this is that's why this is our challenge in here. See, all right, let's queue this one first in here. Let's queue Control Shift 6 in here. So beautiful now. Okay, so far, come on. Where's the command again? Control Shift 6, Control Shift 6. Okay, so we kill this trace route command first. We already verify the traffic. We already verify the traffic is come to here because we can see one. Oh, okay, beautiful. Okay, then we look at in here. We look at the internet router. Okay, internet router. First thing, if from the internet router, do I know show IP route? So for example, do I know the show IP route 10 dot, because this is for the return, right? So we know about 60.0 network? Oh, it's beautiful, right? Oh yes, I learned it from the BGP, right? It's via is BGP, right? So now when I show IP BGP, right, I should have it on the table. You see, the 60 where is the 60? 10 down. Do I have a 60 here? Let me show again. Show IPBGP. Yes, here, see the 60. Oh, look at that, look at that, look at that, look at that. I can see from the table now. Look at that. Oh, when you go back to 60 here, look at that. It's taking this side, this one, this one, this one, this one. Oh, it looks good to me, right? Because see, we can see from here. You see, from here, and what is the AS number in here? I assume this AS number is a one. Yeah, this is one. And then one go to three. Beautiful. And then once go to three, it go back to MPLS. Yep, go back to MPLS to see in here because we advertise for here. And then this guy should be go back to here. So this is a 004. Yep. And then go back to the 006. and then go back to 005, and then go back to here. Oh, see, that is funny. See, but from the trace route here. See, from the trace route, outgoing is take this path to here. but then but then the return traffic is take the long path all the way back to MPLS, come back to VPLS. You see, and I have to be crossed to multiple winding come back to here. It's nothing wrong, but only the issue in the future. What we call is a asymmetric routing. Asymmetric routing. That means one going is not taking the same path going back. Okay, it's I mean it's, we call what it call is like asymmetric routing is like we have a multiple routing. Okay, so that is mean is take the return is take different path instead like take the same path from the outgoing. So far so good.
Mm-hmm.
Yeah, so in here. But okay, there's nothing wrong, right? As long as you understand how to come back. I don't sometimes in the network, right? You cannot see it. I don't care where you route from your topology. As long I can ping, you can return. Nothing wrong. It's only something like a network slowdown or maybe network latency, something like that, right? Okay, we're not worried about the optimize, or we're not worried about in the network traffic. We just want to make sure we get ping, we should make a reply. But think about in here, the internet router. You see, I try to refresh again. Okay, I just to refresh your mind again. When you come to this internet router, what you need to worry about in this router? Because you have to remember, right? Because from here we're going to go to outside. Because from the outside world, you see, from the outside world, they do know that your private IP network. They do know that your 10 network, right? In this case, when you ping from the when you ping from this bottom here, the 10.100.60, when you come to here, this router, it should be to help net translation. Remember? So that means you have to be translate this network to your private IP address and go out to internet. And then the internet have to be returned with your public IP address and check on your net table and come back again, return back to you. So far so good?
Mm-hmm.
Yes. Okay. So in this case, you see, we quick in here, we show, right? We show run, you see, section, IP net, you see. Okay, so look beautiful. Look at we have an IPNet source. You see, at least 50 interface. Blah blah blah. We're going to be overload, right? You see, overload this loopback. You see, we can show again, show run interface this loopback. You see in here. You see, this is should be the public IP address. See, yeah, 64 222 Remember, you see here, see, because the ABC we already register, we assume the 64.12.12.0 is belong to ABC. Okay, this is our public IP address. Yep. So we have assigned on this router. So this interface facing go out the internet, right, is using here. So that is mean from outside the return traffic, they have to be go to 64. So that is mean now in here, just for example, you see in here, when we show IPNet, okay, translate like that, we hit enter. We have nothing translate yet. You see, we don't have something like that, right? It's fine. And then let's repeat again because we have a net inside. Remember this one here is the net inside. From the net inside, because we have an access list 50, you see, that is that we try to commit like interesting traffic, allow